Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, can robots tidy up space trash? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week I'm exploring the fascinating world of space robotics. From cleaning up debris in orbit to exploring new planets. But first, I'd like to remind you to subscribe to Robot Talk through your favourite podcast provider to make sure you're the first to hear the latest episodes. Another way to find out about new episodes is the email newsletter, which you can sign up to by going to robottalk.org. To celebrate the 100th episode of Robot Talk, I'm offering a 25% discount on Patreon memberships for the next week. Go to patreon.com/Claire Asher and enter the code ROBO100 at the checkout to claim a discount on your first month's membership. You'll get access to the monthly bonus episodes, behind the scenes updates, and the first 20 supporters will get a free sticker. So don't miss out. Join the Robot Talk community on Patreon today. So, without further ado, let's get on with this week's interview. I recently had a really interesting chat with Mini Rai from Orbit Rise about orbital and planetary robots. This week, I'm speaking to Mini Rai, an honorary professor at the University of Lincoln and director of Orbit Rise, whose work focuses on orbital and planetary robotics. Hi Mini, great to have you on Robot Talk.
Good afternoon, Claire. Thanks for this invitation.
So you've been working in the field of space robotics for over 25 years, most recently in your role as Global Chair in Robotic Engineering at the University of Lincoln. So can you give us a bit of an overview of your research in this field?
Sure. Space robotics is an interdisciplinary field of study that interfaces astronautics and terrestrial robotics. This field emerged due to the challenging task involved in the International Space Station program and various autonomous interplanetary missions. So broadly speaking, space robotics covers orbital robotic missions and planetary robotic missions. There are many research areas on autonomous robotic surface exploration of the moon, Mars, and asteroids. Similarly, in the field of orbital robotics, we work on removal of space debris, in-orbit servicing of satellites, refueling, assembling high-value infrastructures such as large aperture space telescopes, space-based solar power stations, refueling in orbit, recycling in orbit, in-space manufacturing, and so forth. So the field is quite broad, at the same time, very challenging.
Yes, I guess it's one of a small collection of areas in robotics where often you have to make the robot, send it out, and then you kind of can't easily maintain it or check on it or change it after you've sent it on its mission.
Exactly.
I mean, I've been kind of captivated by the Curiosity rover and some of the, the missions to Mars, but they are largely being controlled from Earth, right? They're not autonomous.
Not fully autonomous.
Yeah.
But they have some semi-autonomous capabilities, though the very first Sojourner rover was fully teleoperated, but with very limited autonomous capabilities. But as the field of AI is evolving, we are seeing more promising autonomous systems coming out. And therefore, in the future, we really want to make space robots fully autonomous.
Yeah, it's really exciting. We had an audience question from James via the website.
Mhm.
James says, how stressful is the space environment for many components of the robots? For example, how big of a challenge are the issues of low pressure, atmosphere, temperature, high radiation levels, etc., in space and even in low Earth orbit?
Yeah, as we know, the space environment is very harsh for spacecraft, including space robots. So, when we design space systems, we need to account for these extreme operating conditions on top of the challenges of operating them in remote environment. So, this could be due to radiation, exposure to radiation, or extreme high or low temperatures. Also, operating in vacuum makes it even more difficult to operate orbital robots compared to their terrestrial counterparts.
Hmm.
Further, extreme lighting conditions or contrast conditions and weightlessness issues also makes it very challenging to operate space robots.
Mhm.
So there's a whole suite of challenges we need to address prior to launch and to make sure that the robots or the satellite can operate over longer durations at a lower cost.
Mhm. How do you go about testing a robot on Earth to make sure it can withstand these extreme conditions?
This is quite difficult. Say, for example, in the case of planetary rovers, we do a lot of field trials under simulated conditions or Earth analog conditions.
Mhm.
However, we still have the difficulties of testing them under low gravity or varying gravity conditions. And of course, in the case of satellites, there are mechanisms to do the thermal testing.
Okay.
But when it comes to robots, especially moving robots or satellites with robotic features, we have various challenges in terms of infrastructure on ground that allows us to do full-fledged testing
Mm.
and to make sure the whole design is robust.
Okay. And so you mentioned space debris, and I know this is a growing issue that we've kind of touched on a little bit in the podcast before, but not
Mm.
for several seasons now.
Yeah,
So can
right.
you talk a bit about the challenges around removing debris in orbit, and how robotics is being applied to this?
Yeah, sure. This is another very big area of research for our community. If you look at the statistics from the European Space Agency, it's estimated that there are now around 35,500 space debris objects, which are larger than
Mm.
10 centimeter in Earth's orbit.
Wow.
Further, there are tens of thousands more minor objects that remain undetected.
Mm.
And other orbits have now reached a tipping point, which we call the Kessler syndrome,
Okay.
where human intervention is urgently needed for space sustainability. The harsh operating environments make capturing and removing uncooperative or spinning space debris very difficult.
Mm.
Also, because the technology readiness level is not that high, it increases the risk of the missions,
Right.
making commercial scale cleaning up operations very expensive. So, if you look at the research that has been conducted on different robotics debris capture technologies, well, there are solutions based on net, harpoons, tentacles, and also space robots. The most promising technology is based on autonomous robots, and this is for active debris removal.
Mhm.
And nowadays, there is a very large market for advancing robotic space debris removal by different space agencies, companies, and there are more investors coming forward to support space sustainability. So to really scale up the operation, we need to make sure that satellites are equipped with one or more robotic capture mechanisms, and they are attractive because of the biomimetic capture approach robots
Mm.
offer, and also comparatively it's easier to do the development and testing on the ground compared to other technologies that I mentioned earlier.
Okay. Yeah, you mentioned tentacles. I haven't
Yeah,
heard about
yeah.
that approach. How does that work?
Well, with tentacles, it's also similar to robotics, but these are passive devices which, once deployed, they can grasp on or engulf
Okay.
the target.
Cool.
But these could be passive or active devices.
Mm.
But with robotic capture, this is a fully active operation.
Okay. So are the robots seeking out the debris or are kind of waiting for it to come within a certain range?
No, in the mission concepts that we are working on, we design a chaser spacecraft with robotic capture mechanisms, which
Mm.
then tracks and identifies the debris or debris, multiple pieces
Mm.
of debris, and it determines how to get into the close proximity operation with the target debris, and then it decides when and how to safely capture the debris. So the chaser spacecraft actually follows the debris, get into sync with the
Mm.
debris spinning rate, etc., and then deploys a capture device to capture, to rigidize, and then do the deorbiting of the debris.
Wow. That sounds incredibly complicated. What does it do with the debris once it's captured it?
Yeah, there are different options. So in the early days, often industries thought we must bring them back to Earth. Or in other words, the technologies that was developed looked at how we can deorbit a debris. So basically, the chaser spacecraft capture the
Mm.
debris and it deorbits it into a lower Earth orbit. And then, as it returns back to Earth's atmosphere, it'll burn out. So
Right.
that's one approach. However, because now we are becoming conscious about sustainability, not just on Earth as well as in space,
Mm.
we are looking at more innovative technologies that will allow us to either reuse or repurpose or even recycle these debris in orbit so
Okay.
that we can develop new feedstock for
Mm.
supporting orbital warehouses where we could, in fact, manufacture various parts or assemble spacecraft. So rather than returning them back to Earth, which only helps to pollute the ocean,
Mm.
which is not
Yeah.
recommended, now the urge is to really develop technologies um, to convert these into useful materials in orbit. And this really takes us into a very interesting topic on the circular economy in space.
Mm.
So, in the context of robotics on ground, we talk about circular economy. Very much similar to that, we are in the process of developing capabilities to establish this circular space economy.
That's amazing. Yeah, I guess also the benefit there is you then don't need to use rocket fuel to get them out of the atmosphere again because you're doing it all in space.
Yeah, so there will be a lot of cost saving provided we have technologies that are viable.
Mm.
So there is a lot of trade off, and these are some of the exciting projects we are working on.
Yeah, that's really exciting. I'm guessing that that's some way off being actually ready to be deployed at this stage.
Yeah, so we are very much hoping to change the art of space debris removal and mitigation.
Amazing. So you very recently moved on from your role at the University of Lincoln to found your own company called Orbit Rise. So can you tell us a bit about this new adventure?
Yes, it's indeed a new adventure. Since 1996, I have worked on numerous space engineering and robotics projects. Although I started as a theoretical researcher, I swiftly became more interested in applied research and
Mm.
enjoyed working with multiple industries over the years. As a professor, I had the wonderful opportunity to lead blue sky research, supervise researchers, teach the next generation, which I greatly enjoyed. However, I wasn't fully satisfied as there is still a huge gap between academic research and industrial innovation.
Hmm.
I felt I must do more to translate research into innovative solutions that will benefit businesses and our society. My commercial outlook on research, development, and innovation actually inspired me to launch Orbit Limited. This startup business specializes in translating control, automation, and robotics research into innovative real world products and services. Today, through Orbit, I can support industrial collaborators in their space robotic missions and actively steer technology transfer between space and energy sectors because both are extreme environments and we need
Mm.
autonomous robots. Alongside driving technical innovation, I'm also working with various stakeholders on regulatory aspects of space missions.
Okay.
My honorary professorship with University of Lincoln is also helping me tune in with academic research.
Mm.
So my decision to transform from a full-time professorial chair to an entrepreneur wasn't easy,
I'm
but
sure. Yeah.
but I trust it'll be very rewarding for everyone I work with.
Yeah, it sounds really exciting. And yeah, really being able to bridge that gap between academia and industry sounds fantastic.
Thank you.
Yeah, you mentioned briefly there about other extreme environments, and I was wondering about the extent to which there's this crossover between like space robotics and I don't know nuclear robotics.
Yes, indeed. So in the last 10 years, I've been working on various technology transfer applications of space robotics. And two areas where I'm continuing my research is one is in the field of nuclear fission, where we are using robots for decommissioning operations, and we are
Hmm.
using robots for remote waste management. So these are
Okay.
the two areas I have been involved in the nuclear sector, fission industry. Likewise, I'm also collaborating with a UK Atomic Energy Authority on fusion robotics. So, for example, one of the robots that we designed for a large scale upcoming space mission, which is to build, assemble space telescopes in orbit, we are applying the same concept for fusion reactor or the tokamak decommissioning.
Okay.
So we designed a walking robotic manipulator for space telescope assembly, and we are using that technology for decommissioning of the jet tokamak. So there is a
Mm.
lot of synergy because all these are like extreme environments where we need autonomous robotic capabilities.
Yeah, yeah, yeah. It's such an interesting field of research. It must be really exciting place to work.
Yes, indeed.
So, what do you think are the biggest outstanding frontiers in space robotics that you're hoping to see progress on in the next
Mm.
10 to 20 years?
Well, we know that technology is fast advancing and the space economy is also booming. So, in the
Mm.
next 10 to 20 years, we will for sure witness many more exciting space robotic missions, such as removal of multiple space debris. There are also companies pushing the frontiers of robotic refueling and servicing of
Mm.
spacecraft in orbit. Very likely, we will also see the very first space based solar power station beaming power from space to Earth. And of course, there will be numerous cislunar and Martian missions that will also feed into building a promising space resource economy.
Fantastic. I mean, yeah, I can't wait to see all of that come to pass. What do you think in terms of like more exploratory planetary robotics, like, looking for signs of life, for example?
In fact, this is continuing, and there is still a lot of missions in the pipeline that is looking for, say, for example, how we can extract water from the south pole of the moon. When it comes to Martian exploration, there is still ongoing research. There's a big amount of research going into scientific instrument developments for detecting, say, for example, the presence of methane or any other forms of current or extinct lives on planets. So that this is a very big area. Though on one side we are also seeing a large growth in orbital robotics. So surface exploration missions using robots is still one of the most advanced programs, but there will be many more in the near future.
Mm-hmm. Do you have a favorite project or robot that you've worked on in the past?
Indeed, the end-over-end walking robot, the E-Walker, which is a space walking manipulator I mentioned, is one of the most promising technology I have developed as part of various research projects. Okay. And this is what we are using for both space missions. Of course, we are in the feasibility and the prototyping phase. But we are applying this for both the space mission and the fusion robotics. So I believe this technology has a lot of promise for future missions, because when we talk about robotic manipulators, often we are constrained by the workspace. Okay. So if there is a robotic manipulator that can walk, then it offers a theoretically infinite amount of workspace. So, if we can prove this technology in space, that will revolutionize how we will undertake future missions.
Yeah, that's fantastic. Mini, it's been lovely talking to you today. I've been chatting to Mini Rai from Orbit Rise. Thank you.
Thank you, Claire.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. It really helps boost the podcast, so thanks in advance. And if you've got a question you'd like me to ask one of my future guests, you can contact me on social media at Robot Talk Pod, on Patreon at patreon.com/Claire Asher, or at robottalk.org. I regularly announce upcoming guests on all those platforms, and I'd love to include your questions in my next interview. Next week, I'll be speaking to Christos Bergelis from King's College London about microscopic surgical robots. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.